Hi students. In this module we are going to discuss the things what we already learned in set theory. Specifically about the cardinal numbers of the sets, and then the remaining one very important definition or the operation which is linking the set theory with the next topic relations. Okay, that is Cartesian product. So now let me take some examples and explain you how these cardinal numbers can be referred. Let us take set A is equal to set of 1, 2, 3. Say set B is equal to set of 2, 4, 5, and set C is equal to set of 1, 2, 3, 7. If necessary, we will take C. Okay. Now we have three different sets. Now, what is n of A? Check it. Set A has total 3 elements. Already we learned the cardinal number of a set is nothing but the number of elements present in the set. So in the set A, there are 3 elements. Set B is also consisting of 3 elements. 1, 2, 3, 3 elements. Set C is also consisting of total 1, 2, 3, 4 elements. First let us write them. Now I am finding A union B for our next explanation. So first we are taking A union B. A union B means we have to take all the elements of A and B. First we should write the elements of A. 1, 2, 3 are the elements of A, and elements of B are 2, 4, 5. As I told you, the repetition of any element should be avoided. So we will get 1, 2, 3, 4, 5. Now n of A union B, that is nothing but total 5 elements. So n of A union B is 5. Similarly, we find A intersection B. A intersection B means we should take only the common element of A and B. Here common element of A and B are only 2, isn't it? So we write set of 2. So what is n of A intersection B? How many elements are present in this A intersection B? Only one number. So that is 1. Now from the result what we have taken, we find that n of A plus n of B. N of A is 3, n of B is, that is also 3, total 6. Similarly, n of A union B plus n of A intersection B. Check it. N of A union B is 5 plus n of A intersection B is 1. So that is also 6. Now we get the new result. N of A union B plus n of A intersection B, it is equal to n of A plus n of B. Suppose if we take this n of A intersection B to the other side, we will get n of A union B is equal to n of A plus n of B, and this n of A intersection B goes to other side, becomes minus n of A intersection B. This is the first result. Okay. Similarly, when you take these all examples and find one result, you will get this result. You can check it. N of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of A intersection C minus n of B intersection C and plus n of A intersection B intersection C. Okay, now we are coming to the next important definition, that is Cartesian product. Before that, we should know what is the meaning of ordered pair. You see, generally we will write set of 1, 2 to represent a set, and we might have seen these different types of representations. Open bracket 1, 2, closed bracket 1, 2. we must know the difference among these three different representations. Here set of 1, 2 means we are considering only that two elements 1 and 2. Whereas open bracket 1, 2 or closed bracket 1, 2 are not representing the two elements. They are representing infinite number of elements between 1 and 2 or from 1 and 2. Now here the meaning of 1, 2 in open bracket means whatever element you take in this set, this is also a set, infinite set. Suppose I take one element x belongs to open bracket 1, 2. I can say that this x is in between 1 and 2. 1 and 2 are the elements. In between 1 and 2. That means we can take above 1 but below 2. In between 1 and 2, we have infinite number of elements. We can take 1.000 infinite zeros. After infinite zeros, if we write 1, that will be bigger than this one. So such numbers, infinite number of elements we can find in between 1 and 2, that is found in the open bracket. So this is called as open set. Similarly, in closed bracket, if you take x as an element, we will write this as x is the element in between 1 and 2. Here the representation is different. The first one we used only less than, whereas in the second one we have used less than or equal to. That means we can take the elements 1 and 2 also, and the other elements are in between 1 and 2. So 1 and 2 are the elements. In between 1 and 2, as many elements as possible we can take. Infinite number of elements are present in these. So the difference among these three brackets should be understood. Now take only this one. This way of writing, this open bracket 1, 2 is the representation called as ordered pair. A specific way of writing the elements in the open bracket as a pair is called as ordered pair. Okay, how this ordered pair is got? That's what we are going to discuss in this module. That is called as Cartesian product. Okay, the Cartesian product of any two sets, let us take. A is one set, say A comma B are the elements of set A, and B is another set, say C comma D are the elements of B. We use into symbol to represent the Cartesian product of two sets. So here A cross B, the definition is set of all A comma B in open bracket. That means it is an ordered pair such that A is the element got from A and B is the element got from B. Whatever the element A we take in open bracket, that is definitely taken from the first set, whereas B, which element is taken in the second part, that is taken from B. So now with this example we can. So here A cross B is a definition. Now we are solving this. A cross B is equal to set of, now this element A is the first element of the open bracket and this element C is the second element of the open bracket. That means this in this ordered pair A comma C, A is the first element whereas C is the second element. So we should tell them first element, second element. In every ordered pair there will be two elements, first element, second element. So here A comma C is one ordered pair. Similarly with A we can take D also. So A comma D, second ordered pair. Now other all elements are in this B, only C and D are the elements. So there is no other element. We can stop there. Now let us take the second element of set A, that is B. Here first element C. So B is the first element of this ordered pair. C is the second element which is taken from the set B. Now here B is the first element of the next ordered pair whereas D is the second element of this ordered pair. Like that we are getting 4 different elements. Here A, B, B. A, B, B. These elements are taken from set A. C, D, C, D. These elements are taken from set B. Now we will get one doubt, sir. If we are finding B cross A, what may happen? What may happen? B cross A means you have to take all the first elements from set B. So C, comma A. C, comma B. D, comma A. D, comma B. Check them. Here in A cross B we have got A, comma C. Here in B cross A we got C, comma A. These elements are not same. A, comma B is not equal to B, comma A. Suppose if I take the example, you will understand. 1, comma 2, 2, comma 1. If these two are the order pairs given, how you will be representing these 2 points on the graph paper? Here 1, comma 2 means x must be taken. On the x-axis we should take 1 unit. On y-axis we have to take 2 units. Plot the point. Here 2, comma 1 means on x-axis you have to take 2 units. And on y-axis you have to take 1 unit. These 2 points are not same. Similar points are not the same points. They are located at the 2 different places. So this is the concept called as Cartesian product. So remember, Cartesian product is also the very important operation, set operation in the sets. So this is the basic for the next topic, that is relations and then functions. So in the next module we will elaborately discuss how this Cartesian product is making the relations, and from the relations how we are getting the functions. Thank you.